Hello, everyone. Thank you for watching again. So for today, I want to go back to basics with NSX-T. And the reason for that is that I'm seeing an awful lot of really great content on really advanced topics. So that's NSX Federation, that's doing bridging, all kinds of advanced use cases. And I was talking to a customer the other day, and what really struck me is that not everyone is as far along on the NSX and network virtualization journey as we often think. You know, if we're heavily invested in NSX, we're working on it on a day-by-day basis. Yeah, you might easily forget or neglect that a lot of people are still very much starting at a journey. So with that perspective, I wanted to do a really basic introduction of network virtualization. So in my last video, I kind of explained how I set up my home lab environment, really simple, really basic. And today I just want to let you see how basic NSX logical switching and logical routing works. And let's start off with switching to a simple diagram. So this is basically what I'm trying to achieve. And it might seem a bit complex. Let's get that video out of the way so you get a full picture. Um, as you can see, I'm really just building a simple three-tier application. So I have I'm gonna try something new here. I have my web tier with two virtual machines. I have an application tier and a database tier. These virtual machines are all connected to NSX segments or logical switches in the old terminology. Um, the logical switches are connected to a distributed router because that's one of the core functions of NSX. The default gateway, so the first hop gateway of every virtual machine, is a distributed router which is deployed by NSX. So what is a distributed router? A distributed router is a kernel module, so it's an in-memory component that's running in each and every ESXi host prepared for NSX. So that means that the default gateway for each virtual machine connected to a NSX segment is always going to be the ESXi server. So that basically prevents us from having to hairpin our traffic all the way to a physical router or a firewall, or more generally speaking, a layer 3 device in our network. So we don't have to traverse that physical link back to the ESXi server. Worst case scenario, um, if Web 01 and App 001 is running on ESXi server 1. So worst case, if you're not using network virtualization, that means the traffic needs to traverse the physical network all the way up to your physical router, then back to that ESXi server, back into the virtualization stack. And yeah, that's basically a really inefficient way of doing routing. So in the new situation, if we're running a distributed router with NSX, then as you can see here, if I want to route traffic from Web 01 to App 01, I'm just hitting the ESXi server, so the distributed router. I'm going to route my traffic into my App 01 virtual machine. It never hits the physical wire. This routing is being done in memory. So this is really powerful, and it really optimizes the way we route traffic in our data center. So what you see here in this diagram is that on the left-hand side, we have the physical view, and on the right-hand side, we have the logical view. The logical view is really simple. It's really basic. It's just a layer 3 device, a router, and it has 3 networks connected with my virtual machines. So if we zoom in a bit on the physical side again, here you can see that to actually route traffic using the distributed router between ESXi hosts. So for example, if Web app02 is running on ESX server 02, and I want to route traffic to that machine from app01, which is running on ESX01. Then we're going to need to hit a physical wire. And the physical wire is basically a single VLAN, a single transport network, which we will use to transport the encapsulated Geneva traffic. Now, Geneva is the network virtualization or the overlay protocol that NSX-T uses. This basically means that if my IPv4 packet, if it hits the TAP interface, so that's the tunnel endpoint interface for the Geneva tunnel, then my IPv4 packet will be encapsulated here, or my Geneva packet will be encapsulated here. It will be transported over a basic IP network. The only requirement is that we have an MTU size of 1600 bytes or larger, so we can accommodate the encapsulation. Most implementations you'll see MTU size of 9000, but basically all we do is encapsulate the traffic or the packet. We transport it across an IP network to the other ESXi server. The TAP interface here does the de-encapsulation, and it gets routed to Web02, which is running on there. Now, this might all seem a bit complex. So what I want to do now is dive into a demo into my demo environment and let you see how we configure this topology. So in my previous video, I showed you how to set up the transport networking, the transport nodes, the edges, etc., etc. So what we need to deploy distributed routers, which are called T1 and T0 gateways. You can forget the T0 and T1 terminology for now. I will dive into the hierarchy of routing of NSX-T in a separate video. In this demo, I'm simply going to use a tier 1 distributed router, which is running as a kernel module in memory on each and every ESXi server. So what you see here is a T1 gateway, which runs my distributed router, which I'm going to use to connect my 3 segments. So the 3 segments are my web tier, my application tier, and my database tier. So in fancy NSX terminology, these are now called segments. In NSXV, we call them logical switches. It doesn't really matter. These are just the networks to which virtual machines get connected. So if I switch back to my vCenter view, you'll see that these port groups or these logical switches or segments are visible in the vCenter client. So I have my application virtual machine. You can see a small N icon there, which is representative of NSX, of course. I've connected my application virtual machine to this logical switch, my database VM to the database logical switch, and my 2 web servers to the web logical switch. So it's really basic. If I take another view, so if I look at the configuration of my virtual machine, it's just as simple as selecting a logical switch or connecting the network adapter to this segment. So that's really nothing special other than just connecting it. If you want to connect it to a traditional VLAN backport group, then it works just in the same way. Switching back to the NSX view again. So let's take the app segment, for example. The app segment is connected to my tier 1 logical router, which is which runs my distributed router. I configure it with an IP address, so a default gateway address, in a CIDR method of writing it down. So that's 10-0.101.1/24. And here you can see that there's one virtual machine connected, which is my app 001, to this to this segment. So if we take a look at the diagram to see the interface that I just created on the distributed router, we're looking at the application segment, the app segment, and here I configured a .1 and a .1 IP address for the 10.0.101 slash .0/24 segment. So as you can see here, that it does some really smart stuff to make sure that the default gateway is always one hop away. So I can have and this kind of goes against traditional networking rules, but physically speaking, logically speaking, there is only one default gateway. The distributed router is a single logical entity distributed across all the ESXi servers participating in NSX. So as you can see here, I can have a .1 here and a .1 there. If there's a virtual machine, two virtual machines connected to this segment, and they are both running on other ESXi servers, then physically the gateway is different. So switching back to the to my home lab environment again, let's take a look at the other segments. So I'm basically doing the same for my database segment. I haven't connected to the tier 1 gateway, configured an IP address for the default gateway, and the same for the web interface. Okay, so let's take a look at where my virtual machines are running. I'm running app01 and web01 on ESXi01. ESXi02 is running web server 02, and ESXi3 is running my database virtual machine. So let's do some basic tests here. So let's log on to web01 to do some basic ping testing. So I'm going to ping my default gateway. That's successful. If I now log on to web02 and do the same test, so I'm also going to ping the default gateway, then you will see that I'm also able to ping that same gateway, which is actually now the ESXi host 2 distributed router kernel module responding. And that's really interesting to see. What's also interesting to see is if I try to ping the application virtual machine, which is running next side to alongside web01. So that is ping 10.0.101.150. So I'm now routing traffic. Let's switch to my iPad again. So I'm now basically routing traffic from web01 to app01. And this means from a physical perspective that I'm not hitting a physical wire. I'm just routing here. Now, if I want to do the same ping test from web02 to app01, then I'm going to need to traverse the physical wire back up here to app01. So web02, I'm going to ping 10.0.101.150, which is my application server. So this is now traversing. I'm pinging from web01 through my distributed router. It's hitting the TAP interface. It's being encapsulated. It's being transported across the IP network. It gets de-encapsulated by the TAP interface. It gets routed to the application interface. Now, this is basic NSX-T logical routing. So in my next video, I want to dive into a couple of new concepts or constructs. So we're now just talking about a distributed router running on a T1 logical router. And in my next video, I'm going to introduce the concept of a service router, and I'm going to explain and demo the hierarchy of T0 routing and T1 routing. So yes, stay tuned on my channel. Hopefully this was informative. I hope you picked up some new stuff on NSX-T. It's really exciting. I'm just scratching the surface here. So yeah, bear along with me and see you next time. Thanks.